This is tutorial about how to grease and replace bearing of wheel motor of Husqvarna Automower robotic lawnmower. Wheel motor should be greased because over time grease loses its lubrication performance. Lubricant degradation is accelerated if a robotic lawnmower is used during very hot days. Let's say it's 25 degrees Celsius or even higher temperatures. When this happens, the whitish color grease turns over time blackish color and it's no good anymore. Second variant is when robotic lawnmower is equipped with ultrasonic sensors, which means that when this type of robotic lawnmower is moving forward, it's moving forward twice as fast as normally, which puts extra strain on wheel motor and its gearbox. Here is an example what not enough grease or no grease does to the gearbox. As you can see, there is a significant play between the gears and their shafts. How often wheel motor should be greased? With models 420 and 430EX once every 3 years. With models 440 and 450EX ultrasonic sensors disabled once every 2 years. With model 450EX ultrasonic sensors enabled every year. And the first thing to do is split upper and lower chassis. For that download workshop manual. Workshop manual is freely available. Just Google workshop manual Automower and you will find it. Since wheel motors are identical, this means that we can switch them. So mark left one with an L and right one with an R. And after greasing, put left one to the right side and right one to the left side. This is important because most of the time robotic lawnmower is moving forward, which means that most of the time gearbox gears serrations are worn only from one side. If wheel motor is switched to the other side, this means that the wear is also switched to the other side of the serration, which will lengthen the gearbox life. This only applies if gears are put back together exactly as they came out, and therefore we have to mark every gear before it comes out from the gearbox. There's a small zip tie, and just take a smaller scissors and go underneath the zip tie, just like that, and then just cut it. Don't use any kind of knife here because then you might damage the wires. Then loosen up the wire bundle here, just like that. Then remove a wheel motor connection plug by pushing the knob underneath the plug down and then pulling this plug out carefully from the motherboard. Then take a T20 Torx screwdriver and remove those 4 screws here. Then remove wheel motor from the chassis by pulling it out. To remove those screws, Phillips PH1 screwdriver is needed, and since those screws are originally very stuck in there, ratchet wrench or drive handle is needed. So when turning the screwdriver counterclockwise, you can focus more force down rather than into the rotating motion, and therefore there is lower likelihood to damage or strip those heads. Once 4 screws are removed, you can separate 2 and then if you want you can remove this washer and then remove those 4 Phillips PH1 screws here, and using the same method what I just described. If somehow this black screw head got stripped, the head needs to be drilled out and removed entirely, and replace it with this type of screw. Anyway, then remove this part like that. Then remove the carrier with the gears. Also we removed the washer which was underneath, or actually between the carrier and the gears, and then remove this one, and then we need to clean or wipe down everything and then mark every gear here exactly the way it came out. For marking the metallic gears, I'm using round file and just file it just slightly, so you can distinguish the one which is filed from the one side and which is not. For plastic gears, I'm using sharp knife, and I'm just making just small marks here, so I can distinguish which side is which. But this all this work is not needed when some of this gear is damaged, and usually what happens with this type of gearbox, especially when grease is gone, this sun gear is so worn that it's almost unusable, and if grease is added, you will shorten this gearbox life, simply because grease is adding more friction, and sun gear is more prone to slip and damage itself. So do not grease it if it's too worn. You just simply, if you grease it, then you will shorten its life. And I have seen on my experience cases where gearbox lasts only 30 minutes and then the sun gear is gone. So to lose up all the gunk from the ring gear inner serrations, I recommend to drop it into the white spirit or mineral spirit, so that all this gunk would loosen up. I would keep it in this solution for overnight. With the metallic gears, I'm using different kind of cup. Same solution but different cup, so there is a lower likelihood that they will damage. here, and the same applies to planetary gears carrier. Drop it, but drop it nice and slow. The ones which should not be soaked in the solution is plastic ones, because plastic ones can react to the white spirit and they can soften. So I'm just recommending to use brush and brush all the serrations completely clean and inspect all the damages. But usually those plastic gears are pretty durable, and I have not seen any plastic gears so far which are damaged. Then remove this white O-ring, clean it, and put some silicone grease on this, and then put it back, and clean this part as best as you can. After soaking the gears and the ring gear and everything in the white spirit solution overnight, remove them. I like to use a magnet for that, and then clean them using a brush. Then start putting everything back together. Remember, the markings have to be on your side. So, and the grease what I'm using at the moment is ADDINOL multipurpose grease L2MO NLGI, because I think, in my opinion, this gives a better lubrication than normal silicone grease. This ADDINOL multipurpose grease has not damaged so far any of plastic gears, although it's lithium soap grease on mineral oil basis containing solid lubricants such as MOS2 and graphite. And the second thing to note is that NLGI, which means relative hardness of a grease, should be with this type of gearbox 2, not 1.5, not 2.5, 2. If it's too thick, then there is very much friction in the gears, and gearbox can damage itself. If it's too thin, then the grease starts to leak and simply disappears. Also, one thing to note is that do not overfill the casing with grease, otherwise it causes too much friction, and it can actually damage the gears because the gears can't move freely. What literature recommends is that the casing has to be 50 to 80% full of grease. So there has to be 50 to 20% of air in the casing. So this is a good example. Approximately there is at the moment 50% of grease in here and 50% of air. Then add a washer, carrier, another ring gear, then screw the 4 black screws in. Torque spec is 0.8, and then add the plastic gears, markings up, add the grease, and then add the washer, and finally connect those two details with each other so that the label here aligns with the curve here. Torque spec of those gray screws is 1.3 Newton meters, and the assembly of the wheel motor is finished. So before we are assembling this wheel motor back to the chassis, then you need to understand how to screw metallic screws into plastic threads. So you need to turn the screw counterclockwise until you hear a click or you feel a click, and then start screwing this clockwise. One way of determining whether or not wheel motor needs a bearing change is to test its vertical and horizontal play. It has some rotational play, but it shouldn't have any horizontal or vertical play. Here is an example of vertical and horizontal play of a wheel motor, and it definitely needs a bearing change. This is the same wheel motor. It has significant horizontal play, but it also has very small vertical play. Vertical play means that some of robotic lawnmower weight is on planetary gears and sun gear. Sun gear tends to wear out pretty fast if this kind of play happens, especially when in gearbox is not enough grease. To remove two outer bearings of a wheel motor, small puller is needed so that the puller can fit inside this hole entirely. So this was adapted for this feature, and I just hand tightened this nut, which was previously removed, and there is no need to heat this part. This is how far the puller can pull before it goes too wide, and we have to switch things up a little bit. Finish this end pulling. I'm using my own manufactured special tool. So this special tool fits inside this hole. It's slightly smaller, so there is a small play here, and then I'm adding a puller here and then pulling it out completely. Now when this special tool is attached, we can finalize this pulling. So this method works really well. And once this part is removed, clean this up, and underneath this dust is Phillips PH2 screws. Remove them, and when they are removed, then you can separate the plastic flange, then grab outer circlip pliers and remove the circlip. Make sure the circlip is not damaged. If it's damaged, you need to replace it. Replace it, and then we can remove finally the shaft from the bearings. Sometimes it's stuck here, like right now, and then we are left with this part. As you can see, the bearings have been slipping on this shaft, and we have bearings here. To remove those bearings, inner bearing puller for 8mm inner diameter ball bearing is needed. Otherwise you simply cannot remove those bearings. To remove those bearings, my setup is this way, and I'm just really hard to film and remove those bearings, but I'm doing my best. Alright, and as you can see, first bearing is removed this way. So we repeat the same process with another bearing. When both bearings are removed, then what I like to do is to remove this inner circlip. This is not mandatory, but I like to do it because it's so small job, and then we can properly clean this part and also the circlip, and then put the circlip back. Original bearing is 698, and it has metal seal, but I'm not recommending this type of ball bearing. It has a lower moisture resistance. What I recommend is to use same 698, but it has rubber seal, so moisture cannot enter inside this ball bearing so easily. To remove those seals is to use a small needle, go underneath the seal and just try to gently remove it. As you can see, this is pretty well greased, but I like to re-grease it and use proper high quality ball bearing grease. Do the same with the other side, and then put the rubber seals back. To press those bearings in here, my recommendation is to use hydraulic press, but if you don't have access to hydraulic press, use vise. But if you don't have access to vise either, then your only option probably is to use hammer, but there is small likelihood that it will damage the aluminum housing or the ball bearings. Second thing is to note that always press this side first, because the other side is flat, so you have better alignment. Otherwise the bearing can go sideways during the pressing. And do not press two bearings at the same time, one in the each side, or the same thing can happen. And since this is aluminum housing, this will damage pretty easily. When those bearings are pressed in properly and they are completely flat with aluminum housing, then it's time to modify this part. Since we had horizontal play, we need to press this part more inside this shaft. But there is one problem we need to solve first. This shaft starts to protrude from the planetary gear carrier, and if this part protrudes too much, then it might damage those planetary gears, as you can see. So first thing to do is to actually push this part out of the planetary gear carrier, and therefore what I recommend to do is to mark it as well, so the alignment stays the same as it was originally. So this line lines up with the black marker here. For this pulling job, I'm using the same puller what I used previously. No need to heat this part up, and just pull this carrier out of the shaft. Once the shaft is separated from the carrier, remove approximately 1 millimeter of hair with a branch grinder and try to grind it so that this side stays flat. After that, take a flat file and round off the edges, and when it's done, then grab carrier test fit, and then also grab 12.19 millimeter socket, so that we could press this carrier back to the shaft, and be really careful not to press on those pegs here, because they are not very tough and they can damage pretty easily. So you need some kind of tool which supports on the edges, not on the 4 pegs like that. As you can see, the pegs are not supported. It's only the carrier around it which supports it. And then use hydraulic press if available, or vise, or just use a big hammer and press it back together. And make sure you press it slightly more in than it was originally. Once it was pressed in, we develop a small bump in here, both sides, and this is normal. This bump indicates here that this shaft was pressed in more than it was previously, which is good, because now we shortened the distance between this circlip and this carrier, and therefore there shouldn't be any play in here. Sometimes it's needed to grind off both of the bumps so that bearings could fit properly inside, and so that the circlip would lock into the groove properly. After pushing the shaft into the bearings and adding the circlip, there shouldn't be any kind of vertical nor horizontal play. And make sure that the circlip is properly seated inside the groove. To test it, use a hammer and do a tapping test to see if the shaft starts to move. And if it starts to move, it means that the circlip wasn't inserted properly, or there was some other problem. So this is sometimes very time-consuming job to fit the circlip here properly, so that there is no horizontal plane and the circlip is properly seated inside the groove. Next, remove this oil seal from the plastic flange. Originally, this oil seal inside diameter is 8 millimeters, outside 15.5, and width 3 millimeters. But since this 15.5 outside diameter oil seal is very uncommon, I'm using instead 16 millimeter oil seal. But this 16 millimeter outside diameter oil seal doesn't fit properly inside this hole, so I'm using 16 millimeter milling cutter. So milling cutter is completely flat from the tip, and it's basically hones out approximately 0.5 millimeters from the edges, so the 16 millimeter oil seal can fit properly. After fitting this new oil seal in, add a little bit silicone grease and then attach it to the shaft like that, and make sure that those two knobs align with the recess here, and then screws in torque spec is 2.5 Newton meters, and finally press this part back here and make sure you have nut here attached so that this is completely fat with the nut. And when you press, do not press on the carrier, rather press on the shaft, and you can use for that let's say a punch, and then just punch the shaft. If you press on the carrier, you may push the carrier inside and misalign everything. And second thing to note is that do not push this aluminum part too much in, otherwise the wheel starts to rub on the metallic flange edge here. So I would say it's 1 to 2 millimeters difference. How much time does it take to re-grease the wheel motor? Approximately 1 hour. How much time does it take to change out the bearings? Approximately 1 hour. So in total it's 2 hours. Is it even viable to change out the bearings? Yes, if you do it on your own. If you let somebody else to change out the bearings, then probably no. Does Husqvarna sell any of those planetary or sun gears separately? No, Husqvarna does not sell any of wheel motor parts separately. If your wheel motor is worn, Husqvarna wants you to buy a new motor, not to repair old one.